everyone. Today we present to you our research on the cross-account AWS vulnerabilities. My name is Shir, and I lead the research team at Wiz, the cloud security company. With me on the stage is Luttwak, the CTO of Wiz.
Thank you. It's really great to be here. So just a bit of background about the Wiz research team. So it's a team of highly experienced researchers, many of us coming from the Microsoft Cloud Security Group. And the goal of the team is to do groundbreaking cloud research, focused on finding new and unknown vulnerabilities, risks, and attack vectors into cloud environments. So the goal of this research was to answer maybe one of the most basic questions that any virtual system has. When we build a virtual system, we have multiple virtual instances running on the same shared infra. And one of the most basic premises of virtualization is isolation. And in the context of a cloud environment, the question is, if I'm a user with no permissions to the environment, no network access to the environment, can I learn anything about the environment? Can I know what services are being used? Maybe I can read data, write data, run code. Is there any way to break the isolation of cloud environments, specifically AWS environments? That was the research question that we started from. And before we dive into the details, let's look at the specific way the cloud is deployed, just to understand why isolation is so critical, especially for those specific customers that use the cloud in this manner. So it's the deployment model that I wanted to take a deeper look at is called cloud as an extension to the on-premise data center. In that deployment model, the cloud is completely isolated from the outside world. The cloud environment has some kind of a VPN connection to the on-premise, but the company didn't change their strategy. There's a corporate perimeter that is protected by a gateway. And the concept and the basic security strategy the company has is that all traffic going outside of the company must go through the gateway. And that is how they make sure that no one is able to leak data from the organization. Imagine that this kind of company, where the cloud is there, but it's an isolated instance, and they assume that there is no way to leak data from the cloud. What if we found a way to read data from that environment? That would allow an attacker to leak data, to exfiltrate data from the environment without actually going through the gateway, essentially breaking their security strategy. So we wanted to look into a cloud-native mechanism that may break the isolation. Obviously, we started looking into identity.
So we've been researching cloud identities for a long time now, and we are familiar with most configurations. AWS allows users to open cloud resources for identities within and outside the organization, as well as various AWS services. With a specific configuration, any S3 bucket or AWS Lambda and dozens of other services can be accessed from different types of identities. There are three main types of access. One, public sharing. The resource can be publicly exposed, and anyone on the internet can use and access the resource. The other option is to allow access to a specific user, resource, or account. This can be users or accounts of the same account, and this can be users of other accounts. And the third option is to provide access to various AWS services that can perform operations on the resource. In AWS, the mechanism defining the access permissions for cloud resources is called resource policy. Resource policy is a textual policy that allows users to define who can access which resource and what action can be taken on them. In this research, we focused on the flow that always integrates us. What does it mean to grant permissions to an AWS service? Doesn't AWS have all the access it needs? Does it matter what permissions I give an AWS service? Can anything go wrong? It makes a lot of sense to grant permissions to internal AWS services. For those who are unfamiliar with Cloudtrail, this is a service that collects almost all platform events. It is excellent for monitoring, controlling, and securing the environment. You can imagine that the amount of information that Cloudtrail collects is insane, and users must export it to an S3 storage bucket. A user who wants to export Cloudtrail logs to an S3 bucket can simply configure Cloudtrail to do so. This saves a lot of code writing and many API calls. In this case, as we see in the slide, the S3 bucket must grant access to Cloudtrail for it to be able to write to the bucket. This configuration is defined within the bucket's resource policy. From that moment on, Cloudtrail will be able to write the logs to the S3 bucket without any user intervention. Nowadays, cloud users are taking a multi-account approach and managing multiple cloud accounts. For ease of management, Amazon allows some of its services to work cross-account. This means that if I want to collect logs from my entire environment, instead of setting up a logging bucket in each account, Cloudtrail allows me to export all logs from all accounts to one account. For me, as a cloud user, it's enough to set up one S3 bucket that Cloudtrail can write to, and now all my Cloudtrail can export their logs to my account. And that's very cool. This feature is great for large environments as it enables easy management and improves centralized security. But wait, I learned from this behavior that Cloudtrail can write to resources that are owned and managed in other accounts. And for me as a security researcher, it raised a concern. At this point, I was very curious about the cross-account mechanism. Let's see how it works. This is how the default resource policy of the S3 bucket looked like. The policy specifies that Cloudtrail service is allowed to perform put object operation, as we can see in the principal and action fields. Put object permission grants Cloudtrail the ability to write objects to the bucket. So this policy allows Cloudtrail to write objects, yeah, but okay.
Shir, wait. What we're seeing here is a very basic and simple resource policy that we see all the time in AWS, right? We see here a service, Cloudtrail, that has access, put object, into the bucket. So if I want Cloudtrail to write into my bucket, makes sense that I would put the principal Cloudtrail and the action put object. But, so what's missing here? Maybe we can let the audience think about it for a second. What's missing in this resource policy? I gave the Cloudtrail service access to my bucket. What's the problem? But, I mean, we said that it can write across different accounts. How does it know if it's my accounts writing into the bucket or your accounts writing into the bucket? I don't understand how this works.
It's a very good question. Let's check it out. So we logged into our AWS console and we created a new trail and specify an S3 bucket of another account. We know that the S3 bucket was designed to store Cloudtrail records, and the bucket granted Cloudtrail write permissions. You can see in the slide that Cloudtrail keeps the records in the prefix AWS logs / the account ID. We have no control over the path, but it does not seem to be an issue. We clicked save and waited to see what happens. It did not work. No file is created in the bucket, and it remains empty. In an attempt to understand why, we went back to the resource policy. At a second look at the resource policy, it can be seen that the bucket allows Cloudtrail to write only to a very specific path, which is probably why our Cloudtrail failed to write to the target bucket. But wait, we can bypass it easily. When defining logs export in Cloudtrail, one can specify a prefix to which the logs will be written. Maybe, if we enter the permissioned path in the policy, it will be able to write. So we went back to the console, to the Cloudtrail console, and specified the allowed path as seen in the policy into the prefix field, the AWS logs / the target account ID. Now, Cloudtrail must write our logs to the correct path, and it should work. We clicked submit, and yeah, the logs were written to the bucket. We managed to get Cloudtrail to write to bucket of another account, and this is really cool. In the slide, you can see the outcomes of our actions. A bucket owned by another account with Cloudtrail records from our environment. We were really excited about this find. We had no idea that it was possible to manipulate services in AWS to perform operations on other accounts. We wonder if this is a unique, unusual event, or if there is a pattern here that can be repeated with other services. And if so, what other services we could manipulate, and what we could get them to do. So we continued the research. We discovered that AWS Config, just like Cloudtrail, can export findings to an S3 bucket. AWS Config is a service that allows customers to assess and evaluate the configuration of their cloud resources, and just like Cloudtrail, it also writes the configuration findings to an S3 bucket, with a path that can be changed with the prefix field. The same vulnerability we found in Cloudtrail also worked for us in AWS Config, and allowed us to write service findings to buckets owned by other users. What other services could be vulnerable? Can we find a service that will also allow us to read data? We were looking for another AWS services which support cross-account functionality, which means these services can accept resources from other accounts. While continuing the research, we came across a service called Serverless Repository. Serverless Repository allows customers to manage serverless applications. You can imagine a private library of applications very similar to a private Docker registry. Only that instead of storing containers images, it stores Lambda functions. At first glance, it does not seem like a service that performed cross-account operations. But after using it for a bit, we noticed that creating a new repository in the service requires to supply the application as well as other resources like README file and license file from an S3 bucket. For the service to load the application image and its README and license file, it needs permission to the S3 bucket. The bucket must grant the service read permissions. And this is what the service resource policy looks like. This is the official policy from the Amazon documentation. It allows the serverless repository service, as we see in the principal field, to perform get object and basically read any object in the bucket.
Sure, wait. I know the audience here is, there are a lot of hackers here, so I'll let them think about the problem here, knowing that we've already talked about the problem of Cloudtrail a few minutes ago. So we have here, again, a resource policy that looks really great. We have a service repo, we have an action. This time it's get object. It's a more interesting action because it allows us to read data, right? So we have a bucket, and we allow serverless repo to read from our bucket. It's great, but what's the problem? What's missing? And it's a very similar problem to what we talked just a few minutes ago.
I have a clue.
Yeah.
Maybe, as we saw in the Cloudtrail policy, maybe it doesn't know which service is writing, which account is writing. Maybe anyone can use the serverless repository service and make it perform read operations on other customers.
Where's the scoping? You're right. Like we don't see any scoping on this policy. How does it know? How does the bucket know which serverless repo should be reading from it and which should not? It doesn't say. Can it be?
So, as we learned from the Cloudtrail example, there is no scoping or restriction conditions to scope which account is authorized. In fact, Serverless Repository is authorized to access buckets of thousands of customers who use the Serverless Repository service. Every user of the service must provide it permission to pull the application image from the bucket. Due to the nature of the service, the buckets usually store highly sensitive data, such as source code, artifacts, and sometimes also secrets. And here, we suspect a malicious actor could take advantage of the service to access other users' confidential files. So let's check it out. We created a new repository called test, and we used the AWS command line tool to update it and specify a new path from which the README file should be pulled. As you can see in the slide, we are asking the serverless repository to pull the README file from another user's bucket. Serverless repo app number 10 is an isolated bucket owned by another account, and we will try to read from it. Let's go for a demo. So as you can see in my console, I'm using the AWS command line tool to perform update application operation on my repository named test. We will specify the README URL in which the serverless repo will pull our README file, and I will specify another bucket that I don't own, called Serverless Repo app number 10. And we will try to fetch the config.yaml file. Let's give it a try. As you can see in the response, the operation succeeded, and now we have a README file in our repository that, if everything works fine, it was copied from our target bucket. Let's use curl to fetch this file. Wow, this is amazing. We managed to read the config YAML file from the target bucket. And this is a CI/CD file that could contain sensitive information, like this one, which contains Docker registry credentials. If we go to the bucket, we will see this is the bucket in another account. We can see that the bucket objects are not public, as AWS states. And also, all the block public access features are turned on. The bucket also have the resource policy that allows serverless repo to perform get object on the bucket. I enabled the logs monitoring of the bucket and pulled it all to AWS Athena. Here we can see the logs of our operations. And as you can see, the requester of the operation was the Serverless Repository service. And it has no IP address, which will be very hard to track. It looks like a very innocent operation. And this is a very unique thing. So this is insane. Performing get object operations on any serverless repository bucket is definitely not intended. And this proves that there is a pattern here. A serverless repository bucket may contain sensitive information that should never leave the organization. Source code leakage can expose intellectual property, internal architecture, code vulnerabilities, and sometimes even hard-coded secrets and passwords. And the bucket may have other uses besides storing the serverless application and may contain other sensitive data. However, in order to exploit the vulnerability on a real target, the attacker will need to know the names of the objects they wanted to read. The names can be anything and requires prior knowledge of the target, or to combine the vulnerability with additional techniques. There is a high risk of such vulnerabilities that they allow exfiltration of data out of the organization without any incriminating indicators. As we've seen in the logs, the data exfiltration is done by the serverless repository itself and looks like a routine and innocent activity. Everyone trusts Amazon services, and such an action will not be revealed even in the most isolated organizations.
So, what have we seen so far? Basically, we broke the isolation. We showed you here 3 vulnerabilities in 3 different services that we were able to write and read data. And we have several more vulnerabilities currently in this closure process, some of them even allowing to run code. Now, these are just the services that we looked at, but this is just the tip of the iceberg. There's hundreds of services in AWS, and many of them are getting more and more cross-account capabilities, because cross-account is the main strategy today for organizations using AWS. So the attack surface is just growing, and what we understood is that any service that performs cross-account actions might be in the risk to be manipulated by an attacker to perform actions on the isolated customer account. So this is really, in our view, a new class of vulnerabilities, cross-account vulnerabilities, and there will be many, many more coming as we look into more services. So now I want to take you to the second part of this talk. What we learned about the process of fixing cloud vulnerabilities, what works about it, and what is completely broken. So let's take you through the timeline. Let's start from the time we actually sent the report. So this was around November, and AWS team worked with us, fixed this really quickly. So around January, all of the vulnerabilities were completely fixed. And they responded, they notified customers, everything went as planned. Basically, the AWS team fixed and completely closed AWS Config and Cloudtrail vulnerabilities. How did they do it? So we used a way to use the prefix in order to bypass the AWS logs ability of Cloudtrail to write into a specific folder. So what they did is basically they blocked the ability to have AWS logs inside this prefix. And that closes the vulnerability. Emails were sent to customers and also notifications sent in the personal health dashboard. So it seems like this vulnerability was completely closed. We should say that it was closed only for customers that really go and actually take the documentation from AWS and do exactly as it says, right? Because many customers close the vulnerability for this, but if they just did Cloudtrail and they gave access Cloudtrail to the entire bucket, what we've seen many customers did it, because again, we trust AWS services, then they're still susceptible to this vulnerability. This is the kind of notifications that AWS sent customers that this kind of prefix AWS logs will not be available after this date. So now to the second vulnerability that was fixed. That's even more interesting. So AWS did here exactly what you would expect. The problem was scoping, so they added a scoping condition. So you can actually say you can access this bucket from serverless repo, but only from a specific source account. That's great. They also sent users notifications, and they also send notifications in the personal health dashboard. Perfect. And also the fix looks great. This is exactly what you would expect. You would expect this. Now we have a condition that specifies the source target. So if I am using serverless repo, I need to state exactly which account is allowed to access the bucket. So everything at this point looked great. We found a few vulnerabilities, AWS fixed them, and we thought it's over. Then what happened is that we looked after a few months in the environments that we can survey, and we tried to see what is the current status. And there we were completely surprised. 5 months after those vulnerabilities were closed, majority of customers were still vulnerable. In fact, our surveys showed that 90% of the serverless repository buckets were still vulnerable to the vulnerability that we found. 90%. How can that be? It was all fixed. The AWS team acted quickly, sent notifications. How can that be that the vulnerability is still there? So we started thinking about it. And the more we thought about it, we understood that the entire process of handling cloud vulnerabilities is completely broken. We looked into that, we looked into the environments. What we understood is that the users, even though some of them got emails, the users are responsible to fix this vulnerability. AWS cannot fix it. If they could, they would have fixed it on their own, but they can't, because they cannot know what was the source account that you meant as a user. So the users need to fix this vulnerability. And the problem is that they simply don't. They lack awareness. The security teams don't even know the vulnerability exists because the security teams are not getting those emails. Imagine you are a security team and you have hundreds of different accounts. Usually you don't even have permissions to the account. How can you know there is an email waiting for one of the account managers? And how many emails are being sent? How do you know this is an important fix to do? And this is the reason that those fixes didn't actually occur. And the more we thought about it, the more we understood this is a big, big problem. So we had two main takeaways. The first takeaway related to the research that we've done on cross-service access is that service access is a new type of cloud exposure risk. Whenever we give access to a service, until now I thought it's okay, I trust AWS, so I trust AWS services, so I can give them any access that they want. But that's not true. If you give access to a service, an attacker, as we saw here, and again, we saw just a few examples, an attacker might be able to manipulate the service in order to access your resources. So the new way to think about service access is that service access is a type of cloud exposure and needs to be handled like cloud exposure. What permissions are we giving the service? Why? Can we scope it? Did we scope it? Did we give any service access that wasn't supposed to be given? Now, this is great as a high-level recommendation, but the reality is this is really hard because each service has a different way to scope. As we saw, Cloudtrail is using a path, and a serverless repo has a condition. And some services don't even support those conditions yet. And what we saw is that it's not only about the complexity of the services,
Some of the vulnerabilities we found, they persisted because we actually found GitHub projects that still contain the code that was before the condition was added, right? So it's vulnerable code. And users keep using them. So the problem may arise from different templates and code, infrastructure as code that you're using that still has vulnerable code. And it's even worse than that. Every few weeks, a new cross-account service gets new permissions. Like you see different blogs by AWS about Cloudtrail, about Glue, AWS Glue getting cross-account access to Kinesis, or CodeBuild getting cross-account capabilities, or SES getting cross-account capabilities. Any of these services, a day before this was announced, the same resource policy was not vulnerable. Once it becomes cross-account, it becomes vulnerable. How can I track all of that? So there's infrastructure as code, there's new services, there's different conditions. It's impossible to track that. How am I able to expect the users, the security teams, to track all of those notifications? And that led us to the second takeaway. And I think this takeaway is probably bigger than the specific research that we did. This is around cloud vulnerabilities. The process is broken. Email notifications are definitely not the solution. We cannot expect a security team to track email notifications, usually don't even get them. And there's hundreds of changes in cloud providers every day. They don't even know the security implication. How can we expect the security teams to track that? And even more than that, we are a cloud security company. We found a few vulnerabilities, and I want to notify customers. What am I supposed to tell them? Hey, you have Shir vulnerability number 1 and Shir vulnerability number 2. But how do I tell them there's a vulnerability? And even more than that, I want to share the vulnerabilities that we found with the industry, with practitioners, with other cloud security companies. How am I supposed to do that? What's the format to do that? It feels like there's a bigger problem here that we need to fix. There's a maturity problem here. And as the more we looked into it, the more we talked with people from the industry, we understood the same problem was already fixed in a different domain. 20 years ago, in 1999, the CVE system was born. Why did we invent the CVE system? CVE was a way to identify and create a central database for all vulnerabilities in code. Because before we had the CVE system, every vendor and every customer were managing code vulnerabilities in their own separate databases. So you could never understand exactly what vulnerabilities you have and what was fixed. CVE system solved the 3 key problems that we face today in cloud vulnerabilities. Number 1, identification. Instead of having Shir vulnerability number 1 and Shir vulnerability number 2, we should have Cloud CVE 2021-532. We should have a shared naming system so we can identify the vulnerabilities that we found. And when we found those vulnerabilities, we should submit it to someone, right, and get a CVE, a Cloud CVE ID. The second problem that the CVE system solves is the severity. Today, you get an email notification, but you don't know how severe it is. Maybe Shir's vulnerabilities here would get maybe a 6 out of 10 because they're not easy to exploit and the impact is limited, right? So once we have a clear severity mechanism, it allows the security teams to prioritize what to fix and what is not and less urgent to fix. So identity, prioritization, and severity. And the third, which is not less important, is tracking systems, tools that allow you to understand exactly what vulnerabilities you have and what you don't have. It cannot depend on the fact that, hey, in Wiz we found 3 vulnerabilities and there's other customer knows about 2 other vulnerabilities. No, we need a central database and we need tools that tell you exactly which vulnerabilities and what severity you have. Just like we have when we scan container images and I get a report and I will get the same report from all tools. These are the vulnerabilities you have, these are critical, these are high, these are medium, and this is what you have to fix. We should do that for cloud CVEs as well. And we want to leverage this talk as a call for action to the industry. We believe this is the time for the cloud security to become more mature. It's time to create the cloud CVE database. And we at Wiz and the cloud research team and the company, we want to cooperate with anyone with practitioners, with other organizations that are willing to build this cross-cloud vulnerability database. And again, I'm saying cross-cloud because this is not an AWS problem. AWS are security, work with us, they fix the vulnerabilities, they keep thinking about new ways to notify customers. They recently created the access analyzer that will have these kind of notifications as well, but this is not enough. The problem is cross-cloud, and this is an industry problem, and we need to solve it as an industry. And I think it is time. So we would love to partner with any company, or organization, or practitioner that wants to build this shared vulnerabilities database. And for me, this is the most important takeaway from this talk.
So now we would like to talk about further research, both on the other side and also on the community side. Mapping AWS services that have cross-account features takes a lot of time. And Amazon has more than 200 services, and it's very difficult to figure which service have cross-account functionality and which not. For us, what worked best was to go over resource policies in our environment and read AWS documentations. I want to encourage the research community to continue this research in parallel to us and help the community uncover more problematic cross-account functionality. In addition, we believe that cross-account vulnerabilities based on identity issues can also be found in other cloud providers, and there is so much more research to be done in the field. Those of you who would like to research the subject, or in general anyone who has a question or idea, please feel free to contact us. We would love to hear from you. Thank you.